H standard enthalpy atomization equal to plus 435.1 kilojoules of energy. Secondly, if you carefully see CH4 in the gaseous state, I am going to take carbon. It will be now the CH4 is dissociate into carbon as well as four molecules of hydrogen in the gaseous state. Delta A H naught is equal to plus 1665 kilojoules under mole inverse. Third one here we can take sodium in the solid state, which will be converted into sodium in the gaseous state. At last, delta A H naught is equal to plus 108, right? Plus 108.4 kilojoules more inverse. In case of diatomic molecules, let us take in case of diatomic molecules how it will be standard enthalpy formula ఏంటి ఇక్కడ what is the standard enthalpy formula delta A is equal to H naught, right, as you know that H naught delta bond H naught delta bond H naught is the formula for diatomic molecules standard enthalpy atomization. Fifth type of enthalpy, bond enthalpy. What is exactly bond enthalpy? We are going to learn now. It is a little bit a lengthy topic. Let us understand the bond enthalpy. Okay. In bond enthalpy, what we are going to learn? It is the enthalpy change when one mole of a particular covalent bond of a gas, right, or in a gaseous state, covalent bond is broken to form products, right? So now we are learning what we are learning. I said, covalent bond when it is broke or broken, right? So during covalent bond when it is completely broken, what will happen? Especially in the gaseous state. And the gaseous state, covalent bond is broken. Covalent bond broken between compounds. Then it is said as our bond enthalpy. It is enthalpy change only occurs when the covalent bond is going to be broken. Whenever they are breaking, right, to form a products are going to be released. What are the products that are going to form? Ions are going to form. Free radicals are also going to be formed, right? Like calcium ion, potassium ion, sodium ion. Ionic state of a product is going to be obtained when the covalent bond is broken between them. This is known as bond enthalpy. To break that bond enthalpy plays a very important role. It is an endothermic process. Example for bond enthalpy. First one, H2 is there in the gaseous state. We have to dissociate hydrogen and hydrogen here to break the bond between them. Two hydrogen atoms we are going to obtain in the gaseous state. Here, delta H naught, right? So delta H minus H naught. Here not you can take. This one you can write. Okay. Now the energy we can write here for this hydrogen to form two hydrogens from the H2, right? 435.1 kilojoule mole inverse is going to be formed. In the second equation, if you take CH4 in the gaseous state, carbon is there in the gaseous state, plus 4 hydrogens are there in the gaseous state. 4 hydrogens are there in the gaseous state. Delta A H No. Second one in the bond enthalpy. What is the second one? Chlorine I am going to take in the gaseous state. It forms 2 chlorine in the gaseous state, delta chlorine minus chlorine power H power naught. And what will be the energy count here? 242 kilojoules mole inverse. Third one is O2 is there in the gaseous state, whatever it is there in the gaseous state. Two oxygens are there in the gaseous state. Delta O is there in the oxygen state. Oxygen H power naught. And plus 428 kilojoules mole inverse is going to be required. In case of polyatomic molecules, bond dissociation enthalpy is different. Let us take in case of polyatomic structure, bond dissociation. Bond dissociation is completely different. In such cases, bond enthalpy is taken as a mean of all the bonds of same type. Now, CH4 is there now. CH4 in the gaseous state, right? If it is slowly breaking, CH3 in the gaseous state plus hydrogen in the gaseous state, delta bond enthalpy, how much it is? H power naught is equal to 427 kilojoules mole inverse. After CH4, CH3 is there in the gaseous state, CH3 is there in the gaseous state, CH2 is there in the gaseous state, and hydrogen is going to be released in the gaseous state. Delta bond in this case, delta bond in this case, H power naught is equal to 439 kilojoules mole inverse. Now, one more example I would like to take. One more example I would like to take here. CH2 is there here in the gaseous state. CH is will be formed into the gaseous state along with the hydrogen in the gaseous state. Delta bond and H value is equal to for CH2, right? So how much it is? 452 kilojoules mole inverse. Similarly, CH is going to be covalent bond is going to be break in the gaseous state. Carbon gaseous state and hydrogen gaseous state. Delta bond again little amount of H naught energy. It is going to be 347 kilojoules mole inverse, right? All these are best examples. So if you count the total energy now from these equations, how many equations I have mentioned in the C4, CH4, right? So what will be the energy count? You can count 7 plus 9, right? 16, 16 plus 2, 17, 18, 18 plus 7, 25. I'm going to take 5 here, 2 here. Okay, so 1665 kilojoules mole inverse, right? Now, like that, the final value I'm getting here, that is equivalent to. Now, if you count delta A H power theta, not right? Now, here I'm taking CH4 is the main compound. Carbon in the gaseous state, I got 4 hydrogens in the gaseous state, I got delta A H power naught. So delta C minus H power naught is equal to 1 by 4 delta A H power naught, that is equal to 1665 by 4 equal to 416 kilojoules mole inverse. Now the point is delta RH power naught equal to sigma delta bond H power naught. Here I am taking reactants minus sigma delta bond H power naught, and here I am getting products. Okay. Example for this. What will be the best example for this? If you carefully see the example, N2 plus 3H2 gives rise to 2NH3, and delta RH power naught is equal to delta N triple bond N H power naught plus 3 delta H minus H, right? H power naught minus 6 delta N minus H power H naught. So this is the final equation that I got. Okay, right. After a prolonged standard enthalpy and bond enthalpy, we got to know about what is bond enthalpy. After bond enthalpy, we are going to learn about enthalpy of a solution. Second, next type of enthalpy, enthalpy of a solution. Till now we have seen enthalpy of gases, but enthalpy of solutions different. It is the enthalpy change when 1 mole of a substance is dissolved in a specific amount of solvent, right? Why it is so called dissolved? Why? Because it is a solution dissolved in solvent. Okay. Now, example, if you take hydrochloric acid, which gives plus in the gaseous state, when it is reacting with the 10 moles of water in the liquid state, it gives a pure form of HCl plus 10 molecules of water within. Okay. Delta solution H power naught. Why? Because it is solution related enthalpy. Hence H power naught delta solution. Delta solution H power naught equal to minus 69.01 kilojoules mole inverse. Next, in the case of ionic compounds, if you carefully see, in case of ionic compounds, let us take ionic compounds, right? Delta solution H power naught is equal to delta lattice H power naught plus delta Hy, right? H power naught. Now the point is, if there are some restrictions, if delta solution H power naught equal to positive, solubility increases with the rise of temperature. Solubility is going to be increases with the rise of temperature. Okay. If delta solution H power not equal to negative, delta solution H power not is equal to negative, solution automatically it is going to be decreases with rise of temperature. With rise of temperature is not going to be changed here. That is what I am trying to say. Delta solution H naught for sodium chloride. How it will be? Delta solution H naught for sodium chloride solution is equal to plus 4 kilojoules mole inverse. Solubility is slightly affected. Solubility is going to be slightly affected. One more I would like to explain today. Okay, what is that? Let us understand one more type of enthalpy. Enthalpy of dilution. Enthalpy of dilution. Right? Very easy and easy to understand. What is exactly enthalpy of dilution? Okay. Now, enthalpy of dilution is nothing but it is the enthalpy change associated with addition of a specified amount of solvent. Right? Now we are learning enthalpy of dilution. The enthalpy of dilution at a delta D at a delta dilution H power naught. Okay. Now in this case it is the enthalpy change associated with the addition of a specified amount of solvent. Specified amount of solvent, whatever it is there, it is going to be identified by enthalpy of dilution. Example for enthalpy of dilution is HCl is there in the gaseous state plus 10 water molecules are there, already we have seen that. 10 water molecules already we have seen that, right? Say yes or no. Now in this case what will happen, let us understand, which is gives rise to HCl with 10 water molecules. Now delta solution here H power not equal to minus 69.01 kilojoules mole inverse. One more example, HCl in the gaseous state 25 water molecules are added and the reaction is continued. HCl is formed with 25 water molecules and delta solution H power naught is equal to minus 72 kilojoules mole inverse. Now delta dilution H naught is equal to delta solution H naught 25 water molecules minus delta solution H power naught 10 water molecules, that is equal to minus 72 minus 69, that equal to minus the kilojoules of mole inverse of energy, right? Now after enthalpy of